Okay, so we'll discuss about fundamental quantity. Fundamental quantity are generally your independent physical quantity. These fundamental quantity can be broadly categorized into 7 units. Okay, so the first one is your length. This length is measured in meter and has a symbol small m. Next we have mass. Mass is measured in kilogram and the symbol kg. Next you have time, which is measured in second and has the unit small s. Next you have temperature, which is measured in Kelvin and denoted by capital K. Next you have electric current, which is measured in ampere and has a unit capital A. Next you have luminous intensity, which has a unit candela and it is denoted by CD. Next you have the quantity of matter, which has a unit mole and can be denoted by small mol. Fine. After this, we will discuss about the derived units. So what is your derived units? Derived units are those quantities which depends upon your fundamental quantities. Let us take for example speed. Now speed is written as distance traveled by time taken. We know distance traveled is my unit of distance and unit of distance is measured in meter. Similarly, time taken is the unit of time and it is measured in seconds. So I can write unit of speed as meter per second. Right? Similarly, you can do it for acceleration. What does the acceleration means? Acceleration means your speed or your velocity depend upon your time. The rate of change of velocity by time. You know what is the unit for velocity? Meter per second. So meter by second divide by again the unit of time, second. So what happens? This s will go down. Fine. If this s goes down, we have meter by second square. Now if I take this s squared to the numerator, what do I have? ms minus 2. So what is the unit for acceleration? ms minus 2. Clear? Fine. You can do this acceleration one as your homework. Going to the next topic, measuring process. To measure any physical quantity q or your physical value, we denote it by using a numerical value and a unit small u. Fine. Suppose let us take the example of this 5 kg. In this physical quantity, suppose your bag of vegetables weighs how much? 5 kgs. What does this mean? This is a physical quantity, and in this physical quantity, this 5 represents your numerical value and kg represents your unit. Fine. Similarly, I can take the example 500 grams. Again, in this case, this 5000 represents my numerical value and this g represents my unit. Clear? Now note your 5 kg and your 5000 grams are same. Fine. So how they are same? It is same because it is measured in different unit system and it is measured in another unit system. Now this unit system, your kg and the grams, these are your general units. Now your units can be broadly classified into 4 categories. They are your CGS, FPS and your MKS and your SI. Fine. Now let us discuss about CGS unit. In CGS unit, we measured length as centimeter, mass as gram, time in seconds. Next, in our FPS system, which is foot, pound, second, we measure our length in foot, mass in pounds, time in seconds. Next, in our MKS system, we measure our length in meter, mass in kilogram, time in second. And finally your SI system, length in meter, mass in kilogram, time in second. We generally use our SI system for numericals, and this is your standard unit. Fine. Next we will discuss about the dimensions of a physical quantity. Okay. So dimensions of the physical quantity are the dimension of the physical quantity or your fundamental quantity. Your physical quantity are represented in terms of your physical quantity which are raised to some power. Fine. Let us take the example of a physical quantity. Let us say density. Density, we know it is mass per unit volume. Now mass is mass. My volume can be written as length, breadth, height. Volume equals to length, breadth and height. Now mass is a fundamental quantity. Mass is your fundamental quantity and it can be measured in kilogram, which is your symbol kg. We generally denote our mass with a fundamental quantity capital M. We denote this one with capital M. Fine. So mass is represented with capital M. Next, length. Length, we know, is the fundamental quantity length, this length, and length is generally denoted by L and it is measured in meters. Okay, do not get confused. Denoted by L, measured in meters. Fine. Now this is your length, capital L, and it is denoted by capital L. Fine. So in this case, length has a fundamental unit. Length is a fundamental unit which is represented by capital L. So as your breadth, capital L, height, capital L. Now we have 3L. So L into L into L. What does this gives me? How many times you have L? 3 times. So I'll write L to the power 3. So I have M divided by L to the power 3. Now I can take this numerator to the denominator. How? We know whenever we have a negative power, a to the power minus 1 or minus n. Okay, or let us say we have a to the power n. If we write this a to the numerator, it will become a to the power minus n. Fine. So similarly here, if we take L to the numerator, it will become L to the power minus 3. Fine. And in this case, our time. Can you see any unit of time? No. So the time power will be 0. So we have the 3 basic fundamental units: mass, length, time. Fine. These will be my dimensions of any physical quantity raised to some power. In this case, the mass has a power 1, length has a power minus 3, time has a power 0. Clear? Now what I will do is, I will take this power inside the bracket, t to the power 0. Fine. So I have taken this one inside the bracket, m1 L to the power minus 3 t to the power 0. We know anything to the power 0 is what? 1. So instead of writing t to the power 0, I can simply write ml minus 3. This is my dimension for density. Is it clear? Fine. Let us go to the dimensional formula or equation. What does the dimensional formula means? Dimensional formula is the basic representation of any physical quantity in terms of your fundamental quantities. Okay. So suppose you have volume. Volume has a volume. It is measured at length, breadth and height. All this have a unit. Length has a fundamental quantity L, breadth also L, M also L, and we will multiply this L. How many times we have to multiply? 3. So you have L to the power 3. So L cube, and I can take this cube inside. So this is my dimensional formula of volume. Is it clear? Now next is your dimensional equation. What does the dimensional equation means? The equation obtained by equating the physical quantity with its dimensional formula. Clear? So what does this mean? Suppose you have a velocity. Velocity means your distance traveled by time taken, or I can say speed equals to distance traveled by time taken. Now the dimensional formula for distance is length and the dimensional formula for time taken is t. So what I'm trying to do is I am trying to denote my speed in terms of the dimensional formula of distance traveled and time taken. So this is known as your dimensional equation. Or more appropriately, I can say length is denoted by capital L, time is denoted by capital T. So in terms of my dimensions, this will be my dimensional equation. Is it clear? Now again, T is written in the denominator. If I take it to the numerator, it will become t to the power minus 1. So I have L t to the power minus 1, and this is my dimensional formula. Fine. So that's it.